Hi, welcome to Error Bars and DNA Tests. Commentary on Twins Get Mystifying DNA Ancestry Test Results from CBC News. So, hi, this is a quick commentary on a video from CBC News on DNA ancestry kits, which was entitled Twins Get Mystifying DNA Ancestry Test Results. There's a link to the video here at the top of the screen and in the video description below. A common theme on this channel is measurement uncertainties and why they're important in interpreting scientific results. For some examples, you might want to check out the video Why Measurement Uncertainties Are Important, available on this channel. But the recent video from the CBC on DNA ancestry kits is a good, real-life example. In the video, a pair of identical twins take DNA ancestry tests from several different companies. They get different results depending on which company they use, and they get different results from each other. The video also states that a person's results can change with time as the companies update their databases. Clearly, these results have some uncertainties associated with them, and these uncertainties affect the interpretation of the results. To illustrate why these uncertainties could matter, let's say someone takes one of these tests, and it tells them that they are 17% Greek. Without an uncertainty, this number is almost impossible to interpret. Is the person 17 plus or minus 2% Greek, or 17 plus or minus 15% Greek? The conclusions from these two possibilities are very different. In the first case, the person would be pretty sure that they had about 17% Greek ancestry. In the second, there's a significant probability that they aren't Greek at all. Also, in the latter case, it's easy to see how someone who really does have 17% Greek ancestry could get a result from one company showing 30% Greek ancestry and a result from another showing 2%. And all of the above statements ignore more tricky issues like how exactly one defines the word Greek. Also, one more thing. Toward the end of the video, there are some statements that the results of these tests are just estimates and shouldn't be taken too seriously. While the results probably shouldn't be taken too seriously, it's not because they're estimates. All measurements have uncertainties, so all scientific results are estimates. For example, the distance from the Earth to the Sun is 1.496 times 10 to the 8 kilometers. That's an estimate. In fact, it varies between about 1.47 times 10 to the 8 kilometers and 1.52 times 10 to the 8 kilometers throughout the course of the year. Also, the mass of the Higgs boson is 125.18 plus or minus 0.16 GeV. That's also an estimate. Note that there's an error bar. So, no measurement is infinitely precise, but that doesn't mean it shouldn't be taken seriously. So, the question is not whether or not something is an estimate. The question is, how good of an estimate is it? This is why it's important to state and take into account error bars. So we'd recommend taking a look at that video on DNA ancestry tests. You might want to ask yourself how much confusion could be avoided if error bars were correctly taken into account. Oh, and by the way, if you like these videos, it'd be great if you'd hit the like button, subscribe, and pass the channel along to your friends. Thanks.